Another way we can look at this problem is as the addition problem. We would start with 7 positive integer chips, and then we would add 6 negative integer chips. Now that we are working with 0 pairs, we take out our 0 pairs, and once we've collected all of our 0 pairs, we are left with 1 positive integer chip, leaving us with the answer of positive 1. So even though we did addition with our 0 pairs, we were actually subtracting because we took away those 0 pairs to leave us with positive 1. Next we have negative 8 minus negative 5. So if we were working on a number line, we would start with 0, and we would move left 8 spaces because negative 8 means left 8 spaces. And then we have subtraction. Typically on a number line, when we subtract, we move left. But because we are subtracting a negative, it is the opposite of left, which means that we will move right. So from our negative 8, we move right 5 spaces, or the opposite of left. And we land on negative 3. Let's see what this looks like when we keep inverse opposite. We keep our negative 8. The inverse operation is addition, and the opposite of negative 5 is positive 5. Now our subtraction no longer exists. So negative 8 plus 5, we have different signs subtract. So we're going to subtract our absolute values, 8 minus 5. And 8 minus 5 gives us 3. But we're not finished. That's our absolute values. We keep the sign of the larger. And remember that this is the larger absolute value, which is 8, and its original sign was negative, so our answer is negative 3. Let's try another example. Here we have negative 4 minus negative 12 plus negative 9. You know that this is minus negative 12 because we have the parentheses around the negative 12. And this is plus negative 9 because we have parentheses around the negative 9. First we start with our negative 4. So on the number line we start at 0 and we move left 4 spaces to negative 4. Next we're going to take away or subtract negative 12. Well, subtracting is usually moving to the left, but we are subtracting a negative. So that means it's the opposite of left, which means we'll move to the right 12 spaces. And then we're going to add negative 9. If we add, that means move to the right, but the negative sign in front of 9 means to the left. So we're going to move left, or we're going to change left 9 spaces. So we'll move back and land on negative 1. Let's see what this looks like if we try this with integer chips. So we still have negative 4 plus negative 12, minus negative 12 plus negative 9. If we use our integer chips, we have positive integer chips and negative integer chips. So first we start with 4 negative integers. So here we have 4 negatives, and we want to take away 12 negatives. So I'm going to add 0 pairs which means that they will equal 0 to my field here. So if I add a 0 pair, I have more negative integer chips to take away, but because they are paired together, this still equals 0. So how many integer pair or 0 pairs would I need to add? I already have 4 negatives, and I need to take away 12 negatives. So I need 8 more 0 pairs to have a total of 12 negatives. So let's add those. So here I have 1, 2, 3, 4, 5, 6, 7, 8 0 pairs added to the 4 negative ones, and now I should have enough negatives to take away 12. Now that I've taken away 12 negative integers, there's another change. I need to add 9 negative integer chips. So I've added the 9, 2, 4, 6, 8, 9 to this field. But now I have more 0 pairs that I can take away. So I'm going to start marking those off in pairs. 0 pair, 0 pair, 0 pair, 0 pair, so on until I run out of pairs, and all I am left with is 1 negative integer chip. So again, I got the same answer, -1.